So here, this is our next heading. Okay, we already discussed about the graphical method of solution of a pair of linear equations. So we have discussed it, but this is something in detail. So this we have already seen a pair of linear equations which has no solution. We call it inconsistent pair of linear equations. And a pair of linear equations in two variables which has a solution, we call it consistent pair of linear equations. And a pair of linear equations which are equivalent has many or infinitely many distinct common solutions. We call it a dependent pair of linear equations in two variables. Okay, and also the dependent pair of linear equations are always consistent. Now these are the three cases. When we find out a solution, we will have these three cases. So the first one is when the two lines intersect. Okay, in a graphical method, what we are going to do, we are going to use the graphs of the two. So suppose we are going to draw a graph of two equations. So when we draw the graph of the two equations, it may come something like this. So it will intersect at some point. Then we call it has unique solution. This exact point where it intersects, we call it the solution of the given pair of linear equations. So it's a consistent case, and also the graph intersects. So it's a consistent pair of linear equations, and also there is only one solution or a unique solution we have. Now the second case is when we have a graph where the lines are parallel to each other. So suppose the first graph I am getting something like this, and the second graph I am getting something like this. So this graph, two graphs we are getting, it has parallel lines. So these two graphs will never intersect each other. So we will not be able to find the solution of this graph. So there is no solution, and it's a inconsistent pair of linear equations, and also the graph is a parallel line. The graphs are parallel. So this is our second case, as we have already discussed. Now the third case is when, suppose this is our graph, okay, and for the first equation I got a graph like this, and for the second equation also I got the same graph. So that means both are coincident to each other. Okay, so in this case what we will have is, we will have infinitely many solutions. Infinitely many solutions. That is, each point in this graph is a solution for the given pair of linear equations. Each point in this graph is a solution. So these lines may be coincident. So when it is coincident, it has infinitely many solutions. So in this case, we call them independent, and also they are a consistent pair of linear equations. So these are the three cases, and here some examples are given. When it is x minus 2y equal to 0 and 3x plus 4y minus 20 is equal to 0, the lines are going to intersect. How we will check whether they are going to intersect or not? So that's why we are given this. Okay, when the a1 by a2 is not equal to b1 by b2, then they will intersect. So what we will do is, we will try to find out the ratios. So first one here is 1x and 3x. So the ratio will be 1 by 3. Now the second, minus 2 and 4. So minus 2 by 4. So obviously the ratios are not equal. So we can say that here in this case a1 by a2 is not equal to b1 by b2. So here a1 by a2 is not equal to b1 by b2. So then the graphs intersect each other and they have exactly one solution. So this is the case, first case. Now for the second case, we will see. For the second case, what are the equations given? We have 2x plus 3y minus 9 is equal to 0, and 4x plus 6y minus 18 is equal to 0. So that means again the coefficient of x 2 and 4. So 2 by 4 is equal to 3 and 6. 3 by 6 is equal to, the last one is minus 9 and minus 18. So minus 9 by minus 18. So if you see here, 2 by 4 we can write it as 1 by 2 is equal to 3 and 6 also we can write it as 1 by 2, and minus 9 and minus 18 also we can write it as 1 by 2. So both the three ratios are equal. So in this case what happens? We can say the given pair of equations are equivalent or they are coincident lines. So in this case the graph will be a coincident lines and they will have infinitely many solutions. Now for the third case, okay, for the third case what will and here also you have noticed all ratios will be equal. Now for the third case what we have here, we have x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 equal to 0. So here the coefficient of x 1 by 2 is equal to the coefficient of y is 2 by 4 and the coefficient of the constant is minus 4 by minus 12. So this is 1 by 2 is equal to 1 by 2 is equal to 4 by 12, we can write it as 1 by 3. So obviously the last one is not equal. So in this case what happens is that there will be no solution. There will be no solution. So this is in the form of a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, as you can see here. And the lines will be parallel lines. The graph will be parallel lines and there will be no solution. So these are the cases. So we have already discussed it. I hope this is clear. Now let's move to our first question. So we have to check graphically whether the pair of linear equations, okay, some linear equations are given. So we have to check whether it is consistent. If they are consistent, we have to solve them graphically. Okay, so our first equation is x plus 3y is equal to 6 and 2x minus 3y is equal to 12. So these are the two equations. Now we have to check whether they are consistent or not. So to check whether they are consistent or not, what we can do, we can check the ratio of their coefficients. So first a1 by a2. What is a1 by a2? Here a1 by a2 is equal to 1 by 2 and b1 by b2 is equal to 3 by minus 3 and c1 by c2 is equal to 6 by 12. So this we can write it as minus 1 and this is 1 by 2. So what we are getting here, a1 by a2 is not equal to b1 by b2. Okay, so that means here the lines are going to intersect. The lines are going to intersect. That means they has a solution. So when they have a solution, what we need to, so that means they are consistent. They are consistent. So we have to find the solution using the graphical method. So for the graphical method, what we can do is we can take the two equations that are x. So the first equation is x plus 3y equal to 0. Sorry, x plus 3y is equal to 6. And our second equation is 2x minus 3y is equal to 12. 2x minus 3y is equal to 12. So this is our first equation, this is our second equation. So for both the equations, we have to find out points to plot a graph. So let's take the first one. X plus 3y is equal to 6. So here x is equal to 6 minus 3y. Now we have to take points for both x and y to plot the graph. So here when we put x is equal to 0, what we have to put for y? So we need 6 minus 6 here. So to make 3 into 2 should come here. So y should be 2. Now when we put x is equal to 3, what should come for y? So that means here 6 minus 3 should come, and that means y will be 1. Now if we are putting x as, let's say, okay, if we want x as minus 3, what should come here in the y's place? There should be, what should be our y? Y should be 3. So when y is 3, we will have 6 minus 9. So when it is 6 minus 9, we will have minus 3 as our x. Now let's take for the next equation, that is from equation number 2. So from equation number 2, what we will have? We have x is equal to 12 plus 3y, the whole thing divided by 2. Okay, and also what about y? If you want, you can keep it like this. So here x and y. So when we put x as, let's put y instead. So when we put the value of y as 1, what we are getting? Sorry, let's just first check for 0. So when we put y as 0, what we are getting? We are getting x as 6. Now, if we are putting y as minus 1, no, not minus 1. So suppose when we put a y as, so let's just y as minus 2, we will have 12 minus 6. So then 6 by 2 will be 3. So that's about our 2 points. Now we can put y as minus 4. So when we put y as minus 4, 3 into minus 4 will be minus 12. So 12 minus 12, we will have x as 0. So these are the 3. So what we can do here is that we can find out points for each equations and plot the graph. So for equation number 1 and equation number 2, you can find out the points for each equation. So for the first equation, as you can see here, we have done this. Now for the second equation, what you can do is you can write x as 6 plus 3, sorry, you can write x as 12 plus 3y, the whole thing divided by 2. Now using this, you can find out the value for x and also for y. So in this way you can find out the points. So as you can see here, we have found out the points and plot the graph. So for the first, we have when x equal to 0, we have y is equal to 2. So we are plotting it as 0, 2. So 0, 2 will come here. Now for the next 6, 0. So when x equal to 6, we have y equal to 0. So it will come here. Now for the second equation, 0, minus 4. When x is equal to 0, we have y is equal to minus 4. So it will come here. Now the second point is 3, minus 2. So 3, minus 2 will come here. So these are the 2 points. So what you can do is you can draw the graph along the points in order to touch the other graph. Okay, we have to, if the graph is only up to here, what you have to do is you have to extend the graph to touch the other graph. So here the graph is touching the first graph and we are getting a common point as 6, 0. So that will be our solution. The two graphs are intersecting each other and 6, 0 will be our solution. So here x equal to 6 and y equal to 0 are our solution for the given pair of linear equations in two variables. So I hope this is clear. Now moving to the next second question, we have again to solve it in graphically. So we have to find whether the following pair of equations has no solution, unique solution, or infinitely many solution. How we are going to do this? Obviously, we are given two pair of linear equations in two variables. So what we have to do is we have to find the ratio of their coefficients. So first a1 by a2. Okay. So for a1 by a2, what we are getting? First is 5. So 5 by 3. Now b1 by b2. Okay, b1 is minus 8 and b2 is 24 minus 24 by 5. So this will become minus 8 into 5 by 24. So 24 and 8 will get cancelled. This will become plus 5 by 3. Minus and minus will become plus. So that's why. Now the next is C1 by C2. First is 1 and for the second equation we have 3 by 5. So this we can write it as the reciprocal. So this will become 5 by 3. So what we are getting here, we are getting all the three ratios of coefficients as equal. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So that means they are parallel lines. So there is no solution. Sorry, they are not parallel lines. They are coincident lines. Okay, so they are coincident lines. So they have infinitely many solutions. They are not parallel lines. When all the three are equal, we have coincident lines, not parallel lines. Okay, so they are coincident lines. So we have infinitely many solution. Okay. So now you can draw the graph for the two equations. So to make it easier, what you can do is you can just multiply the second equation with 5. Then you will get to 15x minus 24y plus 3 is equal to 0. So this can be our second equation. Now using these two equations, you can draw a graph if you want and find out the solution. So we are asked to find whether the following pair has no solution, unique solution, or infinitely many solutions. So this have infinitely many solutions. So that's our answer. Now moving to the third question. So here Chamba went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered the number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Help her friends to find how many pants and skirts Chamba bought. So here a case or a situation or an instant is given, or we have to represent the given things in the form of variables. Okay, then we can easily find out the actual value of the variables. So here Chamba, she bought what? Pants and skirts. Okay, when her friends asked her how much she bought, she said that the number of skirts is 2 less than twice the number of pants purchased. So what we can do is we can just let's denote the number of pants by X and the number of skirts by Y. So that means this particular sentence, if you see, the skirts is 2 less than twice the number of pants purchased. So here skirts I am representing it Y. So that means Y is equal to twice the number of 2 less than twice the number of pants. So 2x minus 2. So this will be our first equation. Okay, now we have to check for the next sentence. The number of skirts is 4 less than 4 times the number of pants purchased. So here again the number of skirts is, so we can write Y is equal to 4 less than, so that means minus 4. 4 times the number of pants purchased, so 4x minus 4. So this will be our second equation. Now here we can find out the points for x comma y. So from equation 1, what will be x and y? From equation 1 we can say that if we put x is equal to 0, what we will have? Y minus 2. So 0 comma minus 2 can be 1 point, and if we put x as 2, what will be y? 4 minus 2, 2 will be. So 2 and 2 can be 1 point. Now from equation 2, what can be x and y? So here when we put x as 0, what we are getting? Y minus 4. And when we put x as 1, we are getting y as 0. So this can be our next point. Now using this we have to draw the graph. So to draw the graph, you need to use a scale and pencil and take exact measurements. Okay, so this is not coming. So this is our y-axis. This is our x-axis. X dash, x 0, y, y dash. 1, 2, 3, 4, and 5. Here you have to take the measurements correctly, okay? So here 1, 2, and 3. Here -1, -2, -3, and -4. Here -1, -2, -3, and -4. So first 0, comma -2. It will come here 0, comma -2, and 2, comma 2. It will come here. Now we have to join. Sorry, this is not working at all. Okay, so this will come. Okay, this graph will have to. And for the second, okay, we will plot the second graph. For the second, it's 0, comma -4. It will come here, and 1, comma 0. So it will come here. So now when you take the first graph, okay, it passes through 0, comma 1, comma 0 actually. And when you draw the second graph also, it passes through 1, comma 0. And so the answer or the solution will come as 1, comma 0. The two graphs, so the two graphs will come like this. Here at 1, comma 0, they will intersect. So the graphs, they intersect at 1, 1, comma 0. So the solution is x is equal to 1 and y equal to 0. So that means here x equal to 1 and y equal to 0. So that means x is the number of pants. So she bought 1 pant. And y is the number of skirts. So she bought 0 skirts. So that's our answer. I'm so sorry for this. So here the graph will come like this. Okay, so here you can see this particular point is our solution. 0, 1, comma 0 is our solution. I hope this is clear. Now moving further.